All right, for the fourth section of Chapter 9, we're going to be talking about the tangent function. So, it's been a while, but for review, hopefully you remember that on the unit circle, cosine theta is represented by the x-coordinate. And sine theta is represented by the y-coordinate. So if we do a quick little setup here, in quadrant 1, we're on the unit circle, so this is 1, 0, 0, 1, and so on and so forth. Remember, this is like angle theta. This is a radius of 1. This was x. This was y. This point was x, comma, y. We found sine theta to be an opposite over hypotenuse, which was a y over 1, which is just y. And we found cosine of theta to be an adjacent over hypotenuse from that angle theta, which was x over 1, or just x. So as you can see from the diagram, then, tan theta is equal to y over x. And since y is equal to sine theta, we say tan theta is also equal to sine theta over cosine theta. Okay, so this side represents the cosine of theta, and this side really represents the sine of theta. This coordinate is cos theta, comma, sine theta. All right, so now P, let's do some examples. P is the point at which the terminal side of an angle in standard position intersects the unit circle. The measure of the angle is theta. For each point P, the x-coordinate and the quadrant are given. Find the y-coordinate of P, cosine theta, sine theta, and tan theta. Okay, so here's the problem. 3/5, comma, y. It's in quadrant 1. I would like to know the y-coordinate. So I can set up my little unit circle in quadrant 1. And I can label this as my little angle here, theta. And I can say that this x value of 3/5 would label this side. And this side is 1. And I'm looking for what is the y-coordinate. So you should remember from up here also that x squared plus y squared equals 1 squared, or just 1. So we could apply the Pythagorean theorem down here to find the y-coordinate as well. So 3/5 squared plus y squared equals 1 squared. So 9 over 25 plus y squared equals, and I'm going to write it as 25 over 25 because I'm going to subtract 9/25. So I get y squared is equal to 16 over 25, and then take the square root of that, plus or minus. In quadrant 1, though, we're going to be positive 4/5. So this side that we just found is 4/5, y-coordinate 4/5. So now remember, you're on the unit circle here. This coordinate was 1, comma, 0. This coordinate was 0, 1, and I can keep going around. So the cosine is the x-coordinate. So cosine theta is 3/5. Sine is the y-coordinate, 4/5. And then tan theta is equal to y over x, which is 4/5 divided by 3/5. So that's the same as 4/5 times 5/3, or 4/3, because the 5s are going to cancel. Number 2, we're in the second quadrant. So I'm going to go over negative radical 3 over 2. Now I don't know exactly where it is, but I know it's less than 1 because we're on the unit circle. This is 0, 1. This coordinate here, negative 1, 0. This coordinate here is 1, comma, 0. So I know that I'm over negative radical 3 over 2. I don't know my y-coordinate, but I do know my hypotenuse is 1. So now I'm looking for this y-coordinate. So I'm going to do the same exact thing. I'm going to go with negative radical 3 over 2 squared plus y squared equals 1 squared. So negative radical 3 over 2 times negative radical 3 over 2 is positive 3 over 4. Radical 3 times radical 3 is 3. 2 times 2 is 4. Plus y squared equals 1. And I'm going to make this one 4/4 because, again, I'm subtracting 3/4. So I get y squared equals 1/4. And then I'm going to square root both sides, plus and minus. And I am now in quadrant 2, so my y-coordinate would be positive. So the square root of 1 is 1, the square root of 4 is 2. So this y-coordinate now is 1 over 2. So that y-coordinate was 1 over 2. The cosine's the x-coordinate. The sine is the y-coordinate, and tangent is y divided by x, which is, in our problem, 1/2 divided by negative radical 3 over 2, which is 1/2 times 2 over negative radical 3. The 2's cancel, and I get negative 1 over radical 3, which becomes negative radical 3 over 3 when I rationalize that denominator. So that's the work for that. Next one, I'm in quadrant 3. So I have negative 3/5. I'm going to go over negative 3/5. And I'm in quadrant 3, so I'm going to go down y. So now here's y, and then I'm going to go back because my radius is 1 because I'm on the unit circle. I forgot to put in my little right angles there. Okay, so over on this triangle in quadrant 2, theta was right there. And this triangle in quadrant 3, theta is right here. So I'm getting like kind of the, I don't really need these, but if you wanted to say sine and cosine, you'd want to reference the angle or use the angle that's closest to the x-axis. Not the y-axis, the x-axis. Okay, so again, we're at 0, 1, we're on the unit circle. So here we go, negative 3/5 squared plus y squared equals 1 squared. So 9 over 25 plus y squared equals 25 over 25. Subtract 9 over 25. And we get 16 over 25, square root, plus or minus. But this time y is going to be negative. Square root of 16 is 4, square root of 25 is 5. And it's going to be negative because you are in quadrant 3, and y-coordinates would be negative there. So this y-coordinate is negative 4 over 5. So my y-coordinate is negative 4 over 5. My cosine of theta is my x-coordinate, so that's negative 3/5. My sine is my y-coordinate, negative 4/5. Again, my tangent is y over x, or sine over cosine. So it would be negative 4/5 divided by negative 3/5. Well, we already had one up above, and it was basically the same thing. They're both negative, so they're going to simplify to 4/3 again. And then in the last quadrant, I'm going to go over radical 3 over 2. So there's radical 3 over 2 down my y-coordinate back to the beginning, which is the radius, which is 1. And now my theta is right there, closest to that x-axis. And so looking for y, we're going to go with radical 3 over 2 squared plus y squared equals 1 squared. So we get 3 over 4 plus y squared equals 1. I'm going to make that 4 over 4. Subtract 3/4, and you'd get 1/4 again, same as we got on the other one. So now we're going to have square root, plus or minus. So y is going to be negative 1 over 2, because you're in quadrant 4, y coordinates when you plot them in quadrant 4 would be negative. So this coordinate is negative 1/2. Cosine of theta is the x coordinate, sine of theta was that y coordinate, and tan is equal to negative 1/2 divided by radical 3 over 2, which is negative 1/2 times 2 over radical 3. So we get negative 1 over radical 3, which is negative radical 3 over 3 when we rationalize. All right? So it seems like we're doing kind of the same thing over and over here. These triangles I've drawn are very important. All right, next page. What if, however, P is not on the unit circle? Find sine. So now I cannot say that we have 1, 0, 0, 1 anymore. I don't know the length of the radius of this circle, so I'm going to call it R. Okay, so R is radius. So here's theta. Here's x, and here's y. So this coordinate is, just x comma y. In this problem, then, sine theta is just equal to y over r. Cosine theta is equal to x over r, adjacent over hypotenuse. Tan theta is still y over x, whether we have the hypotenuse or not. Now x squared plus y squared equals r squared. And sine squared plus cosine squared is going to actually equal 1. From the unit circle, that was true from the unit circle back on the previous page. So P is a point on the terminal side again, but now it's not a fraction. I'm not on the unit circle. So I'm in what quadrant for 8, 15? 1. Then I'm in quadrant 2 for negative 2, 6, and negative 1, quadrant 3. And looks like I'm again, I think this is supposed to be positive here. So it's supposed to be positive 8. Let me... Okay, so 8, negative 15, so that we can have one in quadrant 4. Okay, so in quadrant 1 then, now I'm going to go over 8 and up 15. I don't know what r is. I can't say it's 1. So here's theta. So I'm going to go 8 squared plus 15 squared equals r squared. And when I do that, I get 64 plus 225 equals r squared. That's 289 square root plus a minus. So r is equal to, because we're in quadrant 1, and radii are always positive, 17. So we now have r is equal to 17. So that was 17. Now we cannot say that cosine is the x-coordinate because you're not on the unit circle. So now cosine theta, we have to refer to the previous page, is x over r. Sine theta is y over r, and tan theta is y over x. So this is going to be 8 over 17. The y is the y coordinate, which is 15 over 17. And y over x is 15 over 8. For the next quadrant, I'm going to go over negative 2 and up 6. Now these obviously are not drawn to scale. They're all identical. So you just have to understand that this is just representing negative 2 and 6 and 8 and 15 and so on. So now here's theta. This is 6, and I don't know r, so I'm looking for r. So I'm going to go negative 2 squared plus 6 squared equals r squared, so 4 plus 36, so 40. So square root, plus or minus, radii of circle are always positive. So this is 2 radical 10. So this is 2 radical 10. So now r, the radius, is 2 radical 10. The cosine is x over r. So it's going to be negative 2 over 2 radical 10. I'm going to rationalize that and get negative, well, the 2's are going to cancel here, so I'm going to get negative radical 10 over 10. Sine theta is y over r, so that's 6 over 2 radical 10. We're in quadrant 2, so sine should be positive there. So 6 and 2 cancel to 3, multiplied by radical 10 over radical 10, and you get 3 radical 10 over 10 for this one. Tan is going to be negative again because you're in quadrant 2. So y over x is just 6 over negative 2, which is negative 3. For quadrant 3, negative 1, negative 1. So I'm going to go over and down and back. Here's theta. Negative 1, there's my right. So I'm going to do, find r. So negative 1 squared plus negative 1 squared equals r squared. So 1 plus 1 equals r squared, so 2 equals r squared. And so radical 2 is equal to r. So this is radical 2. Cosine is x over r, so that's going to be negative 1 over radical 2. Rationalize, and you get negative radical 2 over 2. Sine is y, so it's the same exact thing. And tan is just negative 1 over negative 1, which is 1. All right, last one, quadrant 4, 8, negative 15. So I'm going to go over 8, down negative 15. Here's my radius. Here's my theta. So now I have 8 squared plus negative 15 squared equals the radius squared. So 64 plus 225. So looks like from the first problem, the radius is 17. So the radius is 17. Cosine is x over r, so that's 8 over 17, which is positive in quadrant 4. So cosine's positive there. Sine is y over r, negative 15 over 17, and tan is y over x, which is negative 15 over 8. So some of these are same numbers, they just differ by the sign. We have to remember all students take classes, take chemistry, calculus, whatever. They're all positive in quadrant 1. That's why every single one of them was positive. In quadrant 2, sine is positive. That's the only thing. And you notice the answers that happened. And then in quadrant 3, tan is the only thing that's positive. And that happened for number 7. And in quadrant 4, cosine is positive. So that's the only one that was positive for number 8. All right, almost there. Oh, we just reviewed these. All students take chem. Sine positive, tan positive, cos positive, all positive. That means that's where they're positive. So these are asking you to name the quadrant in which the terminal side of an angle lies. So if sine theta is less than 0, that means that sine is negative. There's my sign for negative, okay? And my sign for positive is that. So sine's negative and cosine is negative. Well, that means then if tan's positive in quadrant 3, then sine is negative and cosine's negative. So we are in quadrant 3. And I also think of it as x and y coordinates. X coordinate and y coordinate are both negative. You'd have to be in quadrant 3. Number 10, sine is positive because it's greater than 0. Tan is less than 0 means that tan is negative. So I'm looking for where sine's positive. Well, sine is positive in quadrant 2 and quadrant 1. But tan is also positive in quadrant 1. And tan is negative in quadrant 2. So it's got to be quadrant 2. Last one of these, I'm looking for cosine to be greater than 0. So I'm looking for where is cosine positive. Tan to be less than 0 means where is tangent negative. So now I'm looking for cosine, we know, is positive here and here. But tangent's positive in 1. Is tangent positive in 4? No. So we are in quadrant 4. Think of these as, again, for number 10, think of plotting a point in quadrant 2. The x would be positive, the y would be negative. I'm sorry, the x would be negative, the y positive. Sine is your positive y coordinate. Tan would be that positive divided by negative. And in 11, cosine is positive, x coordinates are positive. Y coordinates would be negative. Number 12, when tan theta is undefined, find a value of. Okay, so we need to think about when is tangent undefined. So if I look here, tan's y over x, unit circle, okay? It's the only time you'd get undefined. You'd get a 0 on the bottom. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So it appears as though the tangent of 90 degrees equals 1 over 0. That would be undefined. And the tangent of 270 degrees would be negative 1 over 0. And that's also where it's undefined. The tan of 0 is going to be y over x. That's 0 over 1. That's just 0. And the tan of 180 is y over x. That's 0 over negative 1. That's also 0. So these are the ones that I'm looking for. So it's undefined at when theta is 90, 270, and then any coterminal to that. So negative 90, negative 270, etc. So when it's undefined, what is the sine and what is the cosine? Well, the sine is the y, right? Sine theta is equal to the y. So if I look at the y coordinates, they are 1 and negative 1 at 90 and 270. So sine theta equals 1, or sine theta equals negative 1, and that means that tangent's undefined. Now, if you look at the x-coordinate at 90 and 270, they're both 0. So the cosine of theta would have to be 0 for tangent to be undefined. All right, that ends it. Have a good night.